Hello, welcome to my video on probability for independent versus dependent events. This is a video for a flipped class. Before you go too much farther, you need to stop and make sure you have the note sheet. If you don't have them, you can print them off of Edmodo so you can get going with the notes. Alright, so let's get started. Important vocabulary. First thing we need to talk about is independent events. The outcome of an event that does not influence, you need to write that down, does not influence the outcome of another event. An independent event, each time you do it, it's kind of its own event. It doesn't influence anything else. Our first example is flip a coin once, then flip it again. Each flip is independent from the other. The first flip does not affect the second flip. Okay, our second example, you need to write this down. Spinning a spinner, then rolling a number cube. Spinning the spinner is not affected by rolling the number cube. Okay, then you have dependent events. Well, independent, dependent, would probably think that dependent is different, maybe the opposite of independent. So the outcome of an event that is, or that has an impact on the outcome of another. So dependent events do affect each other. Alright, so first thing we can look at is, picking a sock out of a drawer, then without replacing the first sock, you pick another. Seeing these words without replacing is going to be a very big thing. You want to look for those. If you see that, you automatically know it's a dependent event. All right, your second equation that we want to look at real quick, or second example. You spin a spinner that has two equal sections, one red and one green. To play, you spin twice. To win, you must get green, green. So for an example, you guys can watch this real quick. There's nothing to write. You should write down your example too. But to play this game, I would spin the spinner, and I would get red. I lost automatically. I don't even get a second spin because I lost. If I spun the spinner and I get green, let's hope I get green. I got green. Alright, I made it past round one. Round two, I spin again. I get red. I lost. But that time I at least got a second spin because I got green the first time. So that's dependent events. So now, finding the probability of independent events. To find the probability of an independent event, you need to use this type of formula. So we've got probability of the event A and the event B and the event C is equal to the probability of A times the probability of B times the probability of C. We're multiplying the probabilities. We are not adding them. Do not add the probabilities together. So our first example, you're rolling a standard number cube. What is the probability of rolling a 2, then rolling a 4? So we got the probability of 2 and 4. Write this down. You have the probability of 2 times the probability of 4. On a standard number cube, those probabilities are 1/6 and 1/6. Multiply those together, and you would get 1/36. So that's the probability of rolling a 2, then rolling a 4. That it has, you can't roll anything else the first time. It has to be a 2. So let's look at the next example here. What is the probability of rolling a 3, then rolling another 3? So this one, first thing we would want to do. Question 2, what is the probability of rolling a 3, then rolling another 3? So for this one, the first thing we need to do is write down our probability. So we got the probability of a 3 and another 3. So this is going to be the probability of 3 times the probability of 3, which is equal to 1/6 times 1/6, 1/36. It happens to be the same probability that we had with question 1. Question 3, what is the probability of rolling an even number than rolling a 3 or a 5? So this time we've got probability of even and 3 or 5. So the probability of even, we'll go ahead and skip this part right here, and we'll just say the probability of even is 1/2. Don't forget, the reason it's 1/2 is I have 3 out of 6 that are even, so the probability is 1/2. Multiply that. Now, 3 or 5. 3 or 5, that's 2 choices out of 6, so it's times 1/3. 1 times 1 is 1, 2 times 3 is 6. So the probability of getting that particular roll is going to be 1/6. Alright, let's look at our last example here. Our last example, you're rolling a 10-sided dice, then spinning a spinner with 2 equal sections, one that is red and one that is blue. Was the probability of rolling a 7, then spinning a blue? So we have probability of 7 and blue. Okay, well, 10-sided dice means I have 1 out of 10 sections, or 10 sides, times, now our spinner has 2 equal sections, 1 red, 1 blue, so that means I have 1/2. There's your answer. Okay, now we're finding the probability of dependent events. This is tricky, so pay attention. The probability of 2 dependent events is found by using the following formula. The probability of event A and event B is found by doing the probability of A times the probability of B after A. That after A part is very important. So now let's go ahead and look at a little bit farther down. Look at example 1. You have a bag holding a blue ball, a red ball, and a yellow ball. What is the probability of picking a blue ball out of the bag on the first pick, then without replacing the blue ball in the bag, picking a red ball in the second pick? So to help illustrate this, I'm going to quickly draw some just examples. So we have our blue, our red, and our yellow. Alright, so if on the first draw I pull out a blue, that means I no longer have the blue. But on the first draw, the probability of getting a blue is 1 out of 3. But since I no longer have it in the bag, my probability for red after the blue is gone is 1 out of 2. So we have 1/3 times 1/2 equals 1/6. Alright, so let's look at the next example. There are 5 white balls, 8 red balls, and 7 yellow balls, and 4 green balls in the container. What is the probability of picking a white ball out of the bag on the first pick, then without replacing the white ball in the bag, picking a red ball in the second pick? To start this, we need to go ahead and write down our probability. So this is going to be the probability of, let's see, we want to get the white one first, and that's T, and then we're going to do the red on the second one. So that is probability of white times the probability of red after white. Alright, so that gives us, now let's figure out how many do we have in the bag altogether. So let's do a little scrap work over here. 5, 8, 7, and 4. I'm going to add those guys together. Let's see, 4 and 8 is 12. 12, that's 24. We have 24 in there. Alright, so I know that they're out of 24. So the probability of a white one is going to equal, see, there are 5, so it's 5 out of 24. Then the probability of a red after a white, I no longer have 24 in there, I have 23 now. And the red is 8. 8 out of 23. Now I'm going to have to use a calculator for this. So, okay, that gives us 40 over 552. Those are both even, so I can divide by 2. And I get 20 over 276. Those are both even, so I can divide by 2. That gives me 10 over 138. Again, both even, so divide by 2. And that gives me 5 over 69. So my probability is 5 over 69. Circle your answer. Alright, let's look at our last example and then the video is done. You're playing a game at school, at a carnival, called Making Purple. The game uses 2 spinners with 4 sections shown below. To win this game, you must first spin a red on the first spinner, then a blue on the second spinner. What is the probability of winning? So here we go. We got 2 sections that are red out of 4 sections on the first spinner. In our second section, we only have 1 blue. So the first thing we've got, we're going to do probability of red and blue. Okay, now this one, they're actually going to be kind of independent of each other, because first one you'd say I've got 1/2, and then the second one you've got 1/4, and then you can just multiply, and you say, okay, 1 times 1 is 1, 2 times 4, 1/4 is 8, so 1/8.